fundamental quantities, which is also so physical quantities, okay. We have two categories. One is fundamental, okay, and the other is derived. We shall see their property, derived quantities. Okay, so this fundamental is also known as base quantities. Fundamental means the bedrock. Okay, these do not depend, independent on any quantity. It is independent of any quantity. It does not depend on any quantity. But this does depend. It depends on what quantity. It depends on the fundamental. Let me call it the other name, the base quantities. So fundamental quantities are those physical quantities that are independent of any other quantities. While derived quantities are those quantities that depend on the fundamental quantities. Quantities, for example, force as a unit. Okay, so the unit of fundamental quantities is also named after the name. We call the quantity fundamental quantity. So its unit is also going to be units are fundamental unit. That's the name of their unit, fundamental unit. Okay, the units of these units are known as derived unit. Let me call it DU. Now, because I told you the alternative name of fundamental quantity is base quantity, so the alternative name of this is going to be base unit. So if you know a fundamental quantity, it has a fundamental unit. The alternative name of fundamental quantity is what? Base quantity. Hence, we can be talking about base unit. So base unit is the same thing as fundamental unit. Base quantity is the same thing as fundamental quantity. Let's proceed. Now, what are those main functions? Before they are in your text. Okay, let's quickly see them and then go straight to the base quantities. Okay, and then what do we use for their symbols? And then what is the base unit? BU, the base unit. Okay, so what is the first one? The first one that we are familiar with, which we are going to be using in dimension, just know this, MLT. This is mass, length, time. There are 7 of them, but these are the basic 3, mass, length, and time, that we are going to be working with. So even though you see a question that you say mention 3 fundamental quantities, mass is a fundamental quantity, length is a fundamental quantity. Okay, time, this is not temperature. Temperature is also fundamental, but this T is actually for time. So mass, base quantity, which is also known as fundamental quantity. The first is mass. Let's be fast about it. You know the symbol for mass is M. You're not interested. So what is the basic quantity for the base unit for mass? That's the kilogram. Let me write in full, kilogram. Okay, which is what? kg. Let me put that part there. Then MLT, the second is length. It's length, TH or HT, length. Okay, this is symbol for length. The dimension is capital L. Dimension, we work with capital letter. So the dimension for mass is capital letter M. Dimension for length, we shall get to that, is capital letter, for length is capital letter L, and for time, capital letter T. Okay, so what is the unit? From the base unit is meter. There are different units in which length is measured. It can be centimeter, it can be millimeter if it's very, very small. Imagine you pick up, you open a wire, and then you want to measure the diameter, how tiny that is going to be. So it's better to put it in millimeter. You can't be put it in kilometer, because it's going to be very, very small, 0.000. So put it in centimeter, maybe it's going to be 2.1 millimeter. Okay, so we'll see conversion later as well. So mass, length, and time. So the bigger the length, the length or distance, like you are traveling from Lagos to Kaduna, then it does not make sense to be measuring the distance in in meters anymore. We measure it in kilometers. 1,200 kilometers, 1,200 kilometers, 3,000 kilometers. Okay, so how big the length is determines, but the base unit for length is meter. The base unit for mass is kilogram. Time. Okay, time can be measured in, what are the units? Seconds. Can be measured in minutes. Can be measured in hour. Can be measured in days, weeks, months, years. The time they gave back to me, I can't be measuring that time in terms of seconds. Although seconds, okay, time T. The base unit is seconds. Seconds. This is symbolized. Somebody is coming in. Let me check that person. Who is that? Well, hey, is the one. Let me admit him. He came before he exited. Let me. You're welcome, but please stay muted, please. Thank you. Okay. Now, the time they gave it to me, it's been over 4 decades. I spent 4 decades on Earth. This month I completed 40. So I can't be measuring that in seconds, or in minutes, or in hours, or in days. I'll measure so many. So I'll measure it in years. That's the most appropriate one. So I've been living for 40 years. So it's better to measure that time in years. How big that time is determine the unit you're going to use. But the basic unit, okay, the basic unit or the fundamental unit for time is what? Seconds. The fundamental unit for length is meter. The fundamental unit for for mass is kilogram. That's why we have gram, nanogram, and co. How small it is determines which one we use. How big it is determines which one we use. But the base is what? Kilogram. For mass, the base for length is what? Meter. The base for time is seconds. Then let's go to others that, sorry. Let's visit other fundamental quantities that we might not be meeting them very well in this dimension, apart from these three that I mentioned, but we are still going to talk about them. Okay, number 4. Number 4 is, I told you temperature also, so we call it absolute temperature. Absolute temperature. It's a fundamental quantity. Okay, what's the next thing here? This is the symbol. What do we use for here? This is one that you can use T or unit for it. The base unit or fundamental unit. Okay, you can measure in degrees Fahrenheit, degrees Celsius, or something I call it degrees centigrade. You can measure in Kelvin. Kelvin does not have degrees, it's just Kelvin. So Kelvin is the base unit for temperature. Kelvin, okay, symbolized as K. And then, temperature is measured in degrees Celsius. Those ones have degree. You mentioned degree before mentioning them. And Fahrenheit, degrees Fahrenheit. But is amount of substance. Before we go, let's go to those ones that you are familiar with in physics, because amount of substance is you mostly hear that in chemistry. It's a fundamental point. It's a scientific quantity. So that's it. So let's finish this. Current. Okay. What's the symbol for current is capital letter I. But when you get to a higher level, we use small letter I. It's allowed to use small letter I. Okay. Stop chatting me, this girl. So you should be in the class. Okay, so this is current, and then what is the unit? Amperes. Miriam, please send the link. Oh God. Sorry. Please, I can't send the link again. I told her to join early since she shouldn't be disturbing me now. Okay, the unit for this is amperes. You can show it as amps. Okay, and then there is the 6th one of the fundamental quantity or base quantity is luminous intensity. Luminous intensity. It's a fundamental quantity. Okay, so the symbolized as this, and then the unit is candela. The symbol for the unit is two letters, CD, C from here and D here, but small letter CD, candela. Okay, and then the seventh one, amount of substance. This is amount, substance, amount of substance. What is the symbol for that? Small letter N. And then what is the unit for amount of substance? There's a small animal known as mole, MOLE. That is the actual unit, mole, but the symbol is just MOL. MOL. So the symbol for the unit is MOL. So any quantities in physics that you know that you can mention them. They are not, if they do not belong to this category of 7, which is MLT, the one easiest to know, which you are going to be working with under this dimension, they are the MLT, mass, length, and time. Mass, length, time, temperature, current, luminous intensity, and amount of substance. If a quantity is being mentioned, it does not fall to any category of these 7. It's automatically a derived quantity. So there are more quantities known as derived quantities than fundamental. All derived quantity depends on the fundamental quantity for their own specification, description, and everything. Okay, so we shall see how we'll be combining fundamental quantities. Combination of two fundamental quantities, or the combination of the same fundamental quantity twice, like length. Combine length 2 times. Length times length. We are talking about area. Area of, for example, a rectangle is length times breadth. It does not matter whether they call one breadth. What is the unit? Both it's also a length. Okay, let's see the shape. The longer side of rectangle is called length, and we choose to call the shorter part breadth or width. Both of them are length, but that's just so there's a length of a circle coming from the center to touch the circumference. You call it radius. It's a length. Because let's see. So anything that can take the position of length, such as a unit, for example, length of a rectangle is measured in either centimeter. The breadth is also be given. Maybe the length will be 7 centimeters. The breadth is what? 2 centimeters. So long as I can take the unit of any length, it's also length. Anything that can be in centimeter, millimeter, kilometer is known as length. So it has different name in different usage. The distance, we call it, talking about how far is your school to your home. We call it the distance. You can call one displacement. It is regarded as length. So that thing is fundamental. Whether you call it width, you call it radius, you call it distance, you call it displacement, you call it anything. If you measure it in the unit of length, it is also known as length. So it is fundamental quantity. So do not just use the term length only, and then the name does not come as length, you think it is not length. If you can take the unit of length, it is length. So displacement is a length. Okay, distance is a length, radius is a length, diameter is a length, breadth is a length, width is a length. So anything that is not part of this 7 is known as what? Derived quantity. Okay, let's go. Now I said before we see the derived quantity, we will review 2 or 3 basic initial rules. You know this. We need to see this short math needed for this topic. Short math, which is rules of indices. Okay, because time is going. What is rule 1? You have a 10. Let me prefer to use A. And then it's being A raised to power whatever, M, multiply by another same base. You call this the base. I'm not teaching maths now. I'm not going to go into details for that. And then another base raised to another power. What is combining them? And the 2 bases are equal. Okay, we are going to pick one of the bases, which is A. This first exponent, M, this is multiplication. We change. I'm going to stop here. If we have the same base to a power K, and then we see divided by the same base and a different power Y. Okay, this can also be written this way. A to the power K using this vinculum division. Vinculum division, A to the power Y. Base A, but with different, just one single base the first index at the top, K, this division is going to be minus, and then the power, or the index here, Y. Okay, which I'm not going to show example in terms of numbers. Maybe 2 raised to power 3 times 2 together. 2 raised to power 4 divided by 2 raised to power 3. They both have 2 raised to power. Then because it is division, it's going to be 2 raised to power 4 minus, what is it? Power 4 minus 3 is not, is if you have this a to a power, and then it is also, I will show you a number value for this, raised to another power y. One, there are two things about it. It is allowed to switch the indices. This index and this index of them are the same as. Why is this? We can switch. So if you have, for example, 2 to the power 2 multiply then by this power 3, it is allowed, it is the same thing, both of them are the same as 2 to the power 3 then this power 2. Okay, so and it is allowed to multiply the power together, 2 to the power, the first power 2 times 3, or 2, if I'm looking at this 2, okay, this is 2 times 3, I'm looking at this 3 times 2, 3 times 2, which is the same thing as 2 to the power 6. Even 2 in 6 places, 2 times 2 times 2 times 2 in 6 places. So you can see, let's show that they are the same. Let's let you see that they are the same. 2 to the power 2 here means 4, then raised to power 3. And then what is the meaning of 4 raised to power 3? It means 4 by 4 by 4. 4 by 4 is 16. 16 by another 4 is 64. Let's see this. 2 to the power 3 means 2 times 2 times 2. 2 times 2 is 4. 4 times 2 is 8. This is 8. Then square outside. What is meaning of 8 square? It is 64. So it is allowed. So let's now go to the basic dimension that we want to see. So let's see now dimension of physical quantities. What we saw earlier, the definition and what do we call the physical quantities? We said there are 2 of them: fundamental quantity and also derived quantity. Okay, dimension of derived quantities. Do not forget, there are 3 of the quantities that are fundamental that are going to be using most, like they are mass. This is fundamental now. Just refresh you. Mass. What is the dimension for mass? Capital letter M. In fact, the actual way is to put it in this bracket. And length. But we shall be working without this bracket. The dimension for length is L. Okay, MLT. I told you MLT. Do not forget. Then time. The dimension for time is capital letter T. So upon these 3, we are going to be combining them to get the dimension of other physical quantities that are derived. These are fundamental. Mass is fundamental or base. Okay. So what's the unit of mass? Kilogram. What does the mean of that? Kilogram is what? A fundamental unit. Why? Because the quantity that it is a unit to is a fundamental quantity. So its own unit must also be a fundamental unit or base unit. Exactly. So seconds, which is the unit of this, is a fundamental unit. Meters, which is a unit of this, is a fundamental unit. Kilogram, which is a unit of mass, is a fundamental. So let's see. Let's start from basic one. Area is defined as length times breadth. Length times width or breadth. And I told you, both of them are going to be the same unit. So this is like combining 2 lengths together. This is 1 length times What is the dimension in actual sense? We love putting the dimension in equal bracket. It's known as parenthesis. It's actually known as bracket. And then the dimension of this width is also length, but width is centimeter. So we are combining two lengths now. L. This is like L to the power rules. This is L to the power. This is multiplication power 2 is L squared. Why? Because by definition, times width, which is length times, is defined, or times breadth of a box. Length times breadth times height, that is the volume. If you cover this part and just have the length times breadth, the length of a cylinder, this is a cylinder. When it's looking like this, we call your length. They don't call it your length. There are readings on the wall, okay? And then they'll put something to block you and then ask you to read. That thing they call it height. So it's also length. But when you need to L, this is first length. Why is this stuff length? This is power 1, power 1, power 1. So it's going to be what? Length to the power of 1. And from dimension, we can know the unit. What is the unit of volume? It's going to be this, since the dimension is L to the power 3. And we know it is from length. Do you remember the other time that the dimension for area, we got it to be L to the power 2. A single L length has a unit of meters. So this, since the dimension raised to the power 2 is going to be meter squared. So this is the unit of that. And then let's see others one that you know their definition. So long as you know the definition of the quantity, you know that when I believe you were able to listen to the distinction between acceleration and motion. Acceleration, change in position with time. Okay. Sorry, motion means change in position of a particle, and then acceleration, change in velocity. Speed, I wrote it. Speed and velocity, they are similar. It's just that speed, this one that I slash it, speed is distance over time, while velocity is displacement over time. That's why I slash it. So the distance is for speed over time, the displacement is for velocity. So speed is distance over time, velocity is displacement over time. Both speed, both distance and displacement, they are length. Just like height, breadth, whatever, they are all distances and they are all lengths. Okay, so the basic thing about this distance is a length. So I wrote length, I combined the two as length. Whether it's distance or displacement, it is length over time. So what is the dimension for length? It is L. Divided by what's the dimension for time? It is T. Okay, so this T means T over 1. And we refresh that rule of that if we have something that is at the denominator, maybe 1 all over x to the power 2. Okay, when this x goes up to stand alone, it becomes x to the power negative 2. Okay, so if you have something like this before, x to the power minus 3, you can put that x down to be 1 all over x to the power positive 3. So I'm saying I want to I'll look at this L over t to the power positive 1. I wrote this L first, and then this t to the power positive 1, I brought it up, it becomes negative 1. And I said if we know the dimension of physical quantities, we can write the unit. Look at this one, L all over t. L is length. What is the unit? Meters. Divided by is what is called per. You can see t is time, the unit of time is second. So the unit for speed is meters per second, which is also the unit for velocity, meters per second. So if you want to write it in this format, here is it. Unit for L is meter, length is meter, time is second, but this t is having -1, so I put the unit there too. And then we delve into acceleration. Acceleration is change in velocity over time. What matters is it is about velocity over time. So it is here. I'm bringing the dimension for velocity. Copy the dimension for velocity. You can see velocity is Lt to the power -1. So I copied it down here to bring it here. Lt to the power -1. Then divided by, there is time in the denominator because velocity over time. So this is the t. So I wrote this L standing alone. And then this t power -1, here is it, the first one here. And then this t to the power positive 1, which is below this line, I took it up. When take it positive power up, it becomes negative up. If it was negative down before, 4 and you take it up, becomes positive. So this is what happens. So the t minus 1 becomes t to the power minus 2. Please, is this clear? That's what I've been explaining. So I want to add one to this, and then I open room for questioning. Force. The definition for force is what? Mass times acceleration. Mass times acceleration. So MA, you always see F equals to MA. You have seen that formula before most time. F equals to MA. So how do we now find the dimension for force? Combine the two things that you multiply together, mass times acceleration. We know what is a mass is a fundamental quantity, but acceleration is a derived quantity. Mass belongs to MLT. Mention 3 fundamental quantity, MLT, mass, length, and time. The rest, we've seen them. Temperature, luminous intensity, current. So long as you are combining one fundamental quantity with another quantity that is not fundamental, or you are even combining only fundamental quantity, the result of combining 2 or more fundamental quantity is no longer a fundamental quantity. It is a derived. You can see area. We said area is not a fundamental quantity. Area is the combination of 2 fundamental quantities, length and length. Area is length times breadth. That breadth is also a length. So length times length, which is length square. That's why the unit of area is always in square, centimeter square, meter square, millimeter square. What is volume? Length times breadth times height. The 3 of them are length. Length times breadth. Breadth is a length times height. Height is another length. So it is L times L times L, which is L to the power 3, L cubed. Y is the unit of volume in raised to power 3 because the dimension is like that. The way the dimension looks like this way is why we write the unit. So the unit of volume is meters raised to power 3, meter cube, centimeter cube. You understand? So now this is mass. So if you multiply 2 fundamental quantities together, please, the result is no longer fundamental. You have seen that from area. Area is length times length. Length is fundamental. The second length is fundamental, but the result they give you is area. It's no longer fundamental. So how much more if you multiply a fundamental with a derived? A fundamental combined with a derived is a derived. A fundamental combined with another fundamental, whether by multiplication or by division, the result is what? A derived quantity. So force is automatically a derived quantity. And it has the definition mass times acceleration. So the dimension for mass here is capital letter M. Multiply by, what is the dimension for acceleration? I want you to quickly memorize this. Velocity and acceleration look alike in terms of their, so the unit of acceleration, let's go and write it. I forgot. Let's go and write it. You can see it is, this is it now. L t to the power minus 2. L is length, which is meters. T is seconds, and the second has power minus 2. So this is meters per second square. So if you like, you can bring the s down and put it slash and put it divide. So we can write it like this: meters per second. This means division. It's going to be positive now. But if you take it up to go and meet m, becomes minus 2. So acceleration is 2 meters per second square. Velocity is 2 meters per second. So the dimension for velocity, Lt minus 1. When that t minus 1 becomes t minus 2, that is acceleration. So that is that. So I want to copy that of acceleration here. It's going to be Lt minus 2. So remove the multiplication. In algebra, whenever you are multiplying 2 letters together, it is allowed to remove the multiplication sign between them and call them together. So A multiplied by B is AB. So I'm going to remove this. So the dimension for mass is M L T to the power minus 2. Okay, so if you all of you should tell me the dimension for this moment. If you know the definition, moment. Moment is actually force times perpendicular distance. What matters is distance. It's the same thing for work. They both have the same dimension. If 2 quantities have the same definition, then their dimension will also be the same. Now, work is force times parallel distance. You may not hear it parallel. Force times parallel distance. What matters is work is force times distance. Moment is force times distance. In your textbook, you will see what is parallel means along the same line. So you say work is defined as product of work, and distance in the direction of work means distance parallel to it. But moment is force and perpendicular distance. What matters is moment is force times distance, work is force times distance. Open your chart, work out this, find me the dimension for work, or the dimension, which is same thing for the dimension for moment. If two quantities have the same, even though let me let you know again. If you know the unit of a quantity, but it does not follow the definition of a particular quantity, if it has the same unit as it, then their dimension too must be the same.